Henri Poincare spent most of his life in Paris, a city that he loved, even with its uncertain climate. In the last decades of the 19th century, Paris was a centre for world mathematics, and Poincare became its leading light. Algebra, geometry, analysis, he was good at everything. His work would lead to all kinds of applications, from finding your way around on the underground to new ways of predicting the weather.
Poincare was very strict about his working day. 2 hours of work in the morning and 2 hours of work in the early evening. It was in between these periods that he would let his subconscious carry on working on the problem. He recalls one moment when he had a flash of inspiration, which occurred to him almost out of nowhere, just as he was getting on a bus.
And one such flash of inspiration led to an early success. In 1885, King Oscar II of Sweden and Norway offered a prize of 2,500 crowns for anyone who could establish mathematically once and for all whether the solar system would continue turning like clockwork or might suddenly fly apart. If the solar system has 2 planets, then Newton had already proved that their orbits would be stable. The 2 bodies just travel around in ellipses around each other. But as soon as you add 3 bodies like the Earth, Moon and Sun, the question of whether their orbits were stable or not stumped even the great Newton. The problem is that now you have some 18 different variables, like the exact coordinates of each body and their velocity in each direction, so the equations become very difficult to solve. But Poincare made significant headway in sorting them out. Poincare simplified the problem by making successive approximations to the orbits, which he believed wouldn't affect the final outcome significantly. Although he couldn't solve the problem in its entirety, his ideas were sophisticated enough to win him the prize.
He developed this great sort of arsenal of techniques, mathematical techniques, which in order to try and solve it. And in fact, the prize that he won was essentially really more for the techniques than for solving the problem.
But when Poincare's paper was being prepared for publication by the King's scientific advisor, Mittag Leffler, one of the editors found a problem. Poincare realised that he'd made a mistake. Contrary to what he'd originally thought, even a small change in the initial conditions could end up producing vastly different orbits. His simplification just didn't work. But the result was even more important. The orbits Poincare had discovered indirectly led to what we now know as chaos theory. Understanding the mathematical rules of chaos explain why a butterfly's wings could create tiny changes in the atmosphere that ultimately might cause a tornado or a hurricane to appear on the other side of the world.
So this big subject of the 20th century, chaos, actually came out of a mistake that Poincare only spotted at the last minute.
And so the essay had actually been published in its original form and was ready to go out. I mean, in fact, Mittag Leffler had sent copies out to various people. And it was to his horror when Poincare wrote to him and said, stop,
Oh my gosh, this is every mathematician's worst nightmare.
Yeah, absolutely, pull it.
Don't hold the presses.
Yes, absolutely. So in a way, it works.
Owning up